Thanks. Okay, so I'm going to tell you about Flock, big data-driven risk analysis for drones, also an AI component, so let's get all the buzzwords in as quickly as we can. Here with my co-founder Anton. Direct all the difficult questions at him, he'll answer them. So you might have seen us already, doesn't matter if you haven't, I'm going to give you the full run through anyway, so who cares. What are we looking at? We're looking at the commercial drone sector. So we're not looking at military drones. We're not interested in bombing anyone. We're not looking at hobbyist drones. We're not particularly interested in flying around in the park. We're looking at quite an interesting sector, which is growing very, very quickly. Security and surveillance inspections and claims. It's not science fiction. It's happening right now all around the world. It's more difficult in congested cities. It's easier to do things like agriculture and so on. Down the line, we're looking at things like goods delivery. Obviously, everyone here knows all about Amazon Prime, drones delivering goods straight to your houses and to your gardens, and weird spying stuff that can happen with people flying drones. Like, there's lots of problems with drones, and we're going to help solve them. But it's a very exciting industry, and there's lots to come in the next few years. What's the problem? Oh, some numbers. You can tell this is an investment deck that I've just recycled here. So just to get across how exciting the industry is, these aren't our numbers. This is from PwC. So $127 billion, that's the total size of the drone industry by 2020. $5 billion of hardware is going to be sold by 2020 as well. That's per annum, commercial drones specifically. The problem in the drone space is that it's very difficult to identify, quantify, and reduce risks. So what I mean when I say risks, the most obvious one is a drone falling out of the sky and landing on someone's head, or dropping a package which lands on someone's head. A less obvious one might be a drone getting blown off course in a congested space, smashing into the side of a building, breaking a pane of glass, which then falls onto the street where there are pedestrians. And less obvious still might be a drone doing surveillance or security missions, or even just gathering data over, let's say, a bridge or a busy road, and landing in front of a crowded bus. Very obvious risks. Those risks translate into costs if you're a drone operator, and you have to pay the consequences of your actions when you make a mistake, when something goes wrong with your drone, if it runs out of battery, if you're a bad pilot, if your software malfunctions, etc. The drone space is a multi-stakeholder space. So as with many emerging technology markets, there are no rule books on this. It's kind of being written at the moment, and there are lots of different stakeholders. So the fact that you can't quantify and analyze risk very quickly and efficiently in the drone space is problems for lots of these stakeholders. It's obvious that operators struggle because operators want to know what the risks are with their flights, and they want to be able to reduce those risks. Whether you're a person with a controller or whether you're a software autonomously guiding drones, you don't want anything to go wrong. Insurance companies make money by understanding where risk is and how risky something is and quantifying that risk and then selling premiums that reflect the quantified nature of that risk. But they're struggling to do so in the drone industry because they don't know where you're flying and they don't know what the risks are with your flights. And then regulators as well. So there's a big tussle at the moment between operators and regulators and insurers. Who's going to take the lead? Who's going to be the one to say, okay, this is how the drone industry is going to look? The truth is no one really knows right now. Regulators are waiting for private companies to innovate and create cool new technologies which will make us all safe. And private companies are waiting for regulators to say, this is the framework for drones and this is how it's going to look. So everyone has to be involved in this. Regulators want to make the drone industry large and fruitful, but they also don't want to be held responsible when someone has a drone-shaped hole in their head because a drone's fallen out of the sky. So we've come up with a solution that we think solves all of these problems and more, or at least partly. And it's big data-driven risk analysis for drones. We gather loads and loads of data about what's going on in a city. So all of this data is relevant to the risk of your drone flight. If you're flying a drone flight over the Gherkin to take some photos, you're going to want to know how many people are below your flight path. Because if something goes wrong and you fall, you want to know if there are people there. You want to know what real-time traffic conditions are. These are ground traffic, road traffic conditions. You want to know if you land, are you going to land on a bus lane? Are you going to land in a very busy road with fast cars? You obviously want to know where every single building and structure is, and you want as much detail on those buildings and structures as possible, right down to trees and bushes, ideally. And obviously hyperlocal weather. So one of the most risky things that can happen to a drone is it gets hit by an updraft or a strange gust of wind which wasn't expected, or wind conditions around the side of a building aren't expected. These are all big risks in the drone space. We gather this data from third parties, and we gather our own data as well, and we feed that data to drone operators in a way that's very easy for them to understand, whether they're people or whether they're machines. A very complicated diagram. The data comes in, we process it, and then we put out a number. So these are the 4 data sets that we already saw, and we're gathering these from external parties. So we work with third parties who already are experts in gathering this data. It would be silly for us to gather it ourselves. They do a very good job of it already. We also gather data about the drone itself. So we want to know, how heavy is it? How fast is it traveling? How fast can it travel? How high can it go? What's the kinetic energy if it were to fall from its maximum height, etc. And then we gather data about you as an operator, whether you're a software or a human. So we know what flights you've done, we know what's gone wrong in the past with your flights, we know how risky you are as an operator generally, we know what certification you have, etc. We feed that data in real time into our proprietary algorithms. So these are algorithms that we've been working on at Imperial Data Science Institute. Some of you probably study there. And we have a team of experts as well in the drone space their life is understanding drone risk. And we're converting their knowledge, which is caked up inside their heads, and we put it into our algorithms, which allows us to, in real time, convert any given flight, which is a flight path, or any given operator profile into a quantified metric of risk. I'll tell you why that's useful. We enable operators to visualize and minimize risk in real time. So what we see here is the centre of London, and we've built a flight path. Let's say we're starting here and we want to take some photos of the river. We have real-time population density in red, so we know how many people you're flying over. We have traffic conditions as well, and we're going to have building data as well and hyperlocal weather conditions. This outputs your risk, 20, which in this case is a relatively low-risk flight. It can go up much higher than that. I'm going to do the thing that you're never supposed to do at one of these events, which is try and give a live demo. Live demos always work. Here we go. Oh, it's already looking weird. It's already, oh my God, it's working. Okay, so we're seeing real time, it's sped up massively, population density in the centre of London, moving around. So for example, a big red spot might be because a train station is just emptied and lots of people have left. The operator, the drone operator, can plan a flight. So let's say they want to fly a path. Oh, come back. They want to fly a path along here. Probably not very sensible. They're going to fly through this kind of busy area here and over, and they're going to land in a really, really busy part of London. Not very sensible. So when we calculate the flight, we will see that the risk will be quite high on the right-hand side, 49, okay? The operator can then, using our visualization tool, minimize the risk of their flight by moving it away from the obviously dangerous areas. Say a prayer, there you go. So what we're doing is we're allowing operators to visualize risk as and when it appears, alter their flights to minimize their own risk, and then we're quantifying that risk, and we're offering that quantified risk to the operator themselves, allowing them to improve their operations, and we're also offering it to other stakeholders involved. And I'll show you the first one, that is. Oh, this is the demo I was going to give you, but there's no need for it now because you've seen it. Another stakeholder involved is the insurance industry. So insurers desperately want to understand risk. They want to quantify risk. They want to know how risky your flight is. Are you going to crash into someone? Are you going to crash into a bus? So the first route to market for us as a company is to actually sell our analytics directly to drone insurance companies. Not insurance companies using drones, but insurance companies who insure drones. It's actually a requirement if you're a commercial operator or you're getting paid to have insurance for your drone. So we do this, we do the big data-driven risk analysis. That allows for this, because suddenly you know this drone flight's twice as risky as this one, so it'll be charged at twice the premium. And we're licensing our software to insurance companies. And we're working with some of the biggest insurance companies in the world to make this a reality. We were funded initially by grants from Innovate UK, and we're super thankful to them. So if anyone from here is in Innovate UK, thanks guys. We're now working in the Ordnance Survey offices. So if you don't know Ordnance Survey, they do loads and loads of mapping, and they're 225 years old, and they felt like they were getting out of touch and they weren't hip and cool enough. So they decided to invest in and work with startups using their data, and we are using lots of their data, and we're based in their offices now, and we're in talks with some pretty interesting big players at the bottom. Our vision is bigger than insurance or insurtech. We call ourselves an insurtech company now. Our vision is obviously to move towards autonomous guidance. It's the next step from what we're doing. Because what we're really doing is we're pricing risk and we're understanding where risk is in cities in real time so that we can allow operators to change their flights. But what we want to end up doing is allow machines to automatically optimize flight paths. So if you imagine a situation where Amazon or DHL or whoever else are delivering tens of thousands of packages across cities, instead of just going in a straight line, which is a stupid way to do it because you might be flying over public parks or really, really busy roads, what you want is a dynamic system that actually intelligently devises its flight path in real time based on what's going on at the ground level. So here's a quick, dirty mock-up of what we've built, which is a very early stage prototype, so don't judge us, which basically in real time allows you to optimize your flight path in a way that doesn't totally drain your battery, so we're not going to send you around an entire city and back, but which also minimizes your risk. The aim being we want to minimize the risk of a drone flight by 95%. Do I have a quick silly video of that? Maybe? Okay, cool. So you're going to take off here, Amazon, and fly here and deliver some packages. And all we're doing is we're looking at real-time risk, which is obviously sped up, as you can see. And we're going to minimize that risk for you over a number of scenarios. So we're going to play out the scenario across the day and understand when the best time to take off is and what the best route would be so that you can minimize your risk, not land on anyone's head, not crash into cars, avoid bad weather, etc. So, oh yeah, the obligatory slide. We are hiring. We've successfully closed a fund round, and we're looking for full stack developers, obviously with interest in data science, so come chat to us after. We're expanding our team based in London, in Clerkenwell, just down the road. And yeah, that's us. Super happy to answer any questions. Hopefully I can answer them. If I can't, Anton might be able to. Thank you for listening.